Welcome back to our LaTeX tutorial series. In the last video, we started learning how to typeset mathematical equations using LaTeX. We will continue exploring more powerful features of LaTeX mathematical typesetting capabilities. We did our previous typesetting on Overleaf, a popular online LaTeX editor. Once you have finished your work, you can download the generated PDF by simply clicking the Download PDF button on the top right. Let me give you some offline workflow tips. If you are working offline using editors like TextStudio or TeXmaker, it is a good idea to create a dedicated folder for each LaTeX project. Place your main text file and any other related graphics or bibliography files in the same folder. When you start another project, just create a new folder to keep things clean and organized. Let's now explore the \tag function in LaTeX. In the previous video, we saw how LaTeX automatically numbers equations when using the equation environment. For example, when we execute this code, the default numbering is 1. But sometimes you may want to assign your own custom number. For this, we can use the \tag function. When we add \tag and 17 within curly braces and compile this, LaTeX replaces the default numbering with 17, just as we specified using \tag. This is helpful when reproducing equations from published material. Suppressing equation numbering. Now, what if you don't want an equation to be numbered at all? You can simply use a star version of the environment like equation star. When you compile, you will see the equation is displayed nicely but without a number. Another technique is to make use of the noNumber function. This is perfect for intermediate steps or when numbering is not necessary. Display equations. In LaTeX, display equations, that is equations on their own line, can be written in two ways. First, by placing the equation between double dollar signs. The second method is to use the \square bracket environment, which is a recommended one and more modern method. You can see that both methods will produce the equation centered and without numbering. Next up is the align environment, one of the most powerful tools in LaTeX for formatting multiple equations. It is part of the AMS Math package and is perfect for aligning equations at a specific symbol, usually the equal sign. Let us see how to reproduce this equation in LaTeX using the align environment. We will write the align environment like the equation environment. To mark the alignment point, in this case the equal sign, we will place an ampersand just before the equal sign. If we change the position of the ampersand, the equation will look like this. Two backslashes at the end of the line are used to break the lines. As before, if you want to suppress the numbering, write it as align star. If you require selective number suppression, we'll use the backslash no number or backslash no tag. For referencing the equations, we use backslash label and backslash ref. You can see that each equation is aligned at the equal symbol and automatically numbered. This is ideal for writing derivations or systems of equations. Writing matrices. We'll now learn how to write matrices in LaTeX, a very useful feature for anyone working with linear algebra or scientific documents. First, make sure to include the AMS Math package in your preamble since it provides the environments needed for matrix formatting. The simplest way to write a matrix is by using the matrix environment. We'll try to write a 2 by 2 matrix. The matrix should be written either inside a begin equation, end equation environment, within dollars, or within backslash open and backslash close square brackets. We take A and B as the elements in first row, C and D as elements in the second row. The elements of the matrix have to be separated by ampersands. To delineate two rows, we place backslashes. So begin matrix and end matrix defines the matrix environment, and the elements in the matrix are A, B and C and D, and elements in a row are separated by ampersands, and the two rows are separated by putting the double backslashes. When we compile this one, we can see that this creates a matrix without brackets. To add brackets, we use different variants. LaTeX offers several matrix environments for different styles of brackets. So instead of writing begin matrix, We'll write begin p matrix for parenthesis, begin b matrix for square brackets, begin capital B matrix for curly braces, begin V matrix for vertical bars, and begin capital V matrix for double vertical bars. We can create matrices of any size, just separate the columns using ampersand and the rows using the double backslashes. Here is a 3 by 3 example. This is an example of how we write an inline matrix equation. As you can see, we have to write the matrix environment within dollars. If you want to include a small matrix inline with your text, we can use the small matrix environment like this. You can see that the small matrix environment keeps the matrix compact within a sentence. We'll now move on to boxed equations. Boxes are a great way to emphasize important results, highlight final answers, or draw attention to a key formula. LaTeX makes this easy using the \boxed command. As always, make sure to load AMS Math package in your preamble to use \boxed. Now, if we want to write this equation within a box, we'll use \boxed and we'll write the equation within curly braces. And this places a nice box around the equation. You can also use \boxed inline with texts like this. This works well for short expressions with a sentence. You can also use \boxed within an align environment to highlight just a part of a larger derivation. This draws attention to the final expression without boxing the entire equation. In this session, we are going to learn how to use the \color command in LaTeX to add color to your text and equations. To begin with, before using any color command, you need to include the Xcolor package in the preamble of your LaTeX document. That is done by adding the line \use package and within curly braces Xcolor. Once that is in place, you can use the \color command to change the color of text. For example, typing \color within curly braces red will turn the text red from the point onwards. To limit the color change to just a specific portion of the text, wrap the command and the text in curly braces like this. This way, only that specific text will be affected. Now let us talk about using color in math code. You can simply apply the same command to equations. For example, if we put \color within curly braces blue within this equation environment, this will display the entire equation in blue. Another handy command is \textcolor, which works like this. This lets you color a specific word or phrase inline without affecting the rest of the text. If you want, you can define custom colors using the RGB values like so. \define color. Then within curly braces, we have to give a name to the color. I've given the name my orange, and then within curly braces RGB, and the values of RG and B are 255, 127, 0. This has to be placed in the preamble of the document. And then we can invoke my orange in the text like this. And that's it. Just remember, use \color to change the ongoing text or math color. Use braces to limit the scope, and always load Xcolor package to get started. Thanks for following along. We'll meet in the next session.